The focus of this forum today being silicon is most relevant in the changing global scenario as far as the requirement of electronics post-pandemic is concerned. I'm going to talk to you today basically on how India is shaping and what we would like to do in this particular segment. And certainly we also want to make sure that whatever we can do in collaboration with Taiwan should be one of our highlights of today's discussion. So if you look at R&D, which is the engine of growth, R&D is fundamental. It is a building block to a strong innovation system. And R&D and innovation landscape is acquiring significantly different dimensions due to the evolution of 12 major disruptive technologies. I think Mr. Das also talked about it, which is basically mobile internet, automation, Internet of Things, smart systems, cloud technologies, robotics, and 3D printing, energy storage, and you know, there are many of them which are today surfacing and changing the complete R&D landscape. These disruptions are transforming the society from the society 4.0 to society 5.0 with the following features. Like the IoT will connect all people and things, all sorts of knowledge and information will be shared, and totally new value will be born. Social issues will be overcome and humans will be liberated from various types of constraints through automation. Artificial intelligence will free humans from the burdensome work of analyzing huge amounts of information. And the possibilities open to human will expand through the use of robots, automatic driving, cars, and things like that. All this is giving birth to intelligent and smart systems, making electronics and the associated software sector an important element of the smart society. This is giving rise to India's plan to accelerate digitalization by creating a robust communication, computing, and surveillance network based upon 4G, 5G, and tomorrow 6G cellular networks, internet, satellites, use of MEMS, and nanotechnology. This requires a huge, robust ecosystem of semiconductor manufacturing in India. During the pandemic, Indian auto and technology sector faced severe shortage of semiconductors and other high-tech components during the supply chain disruptions. This led to a thought that setting up a domestic semiconductor manufacturing ecosystem is must to make India truly self-reliant. So in the light of this, why semiconductor is critical for India? Because electronics provide the solutions in terms of, for example, in terms of IoT, the sensors and the Internet of Things, the high-speed communication, the big data and computing, energy, which is the green energy for environment control and meeting the energy demand, which is ever increasing. Then, of course, we have a huge quantity of data which is being handled. So security and encryption becomes one of the imperative. Then we have, of course, security, healthcare, agriculture, pedagogy, energy and environment. So electronics is the lifeblood of present and future of any society today. In fact, there has been a statement from Sen Ben Sase, the Senate Select Committee on Intelligence, USA, who said that, to quote, modern wars are fought with semiconductors. And there is another one who, Mr. Maruf Raja, the strategic analyst of our Times of India, who said the Chinese agenda is to have access to abundance of water to manufacture microchips. So see the gentlemen, what is the kind of importance today this semiconductor, hence the silicon becomes very important. Now, what is the requirement of India? Because we have our aims as far as the semiconductors are concerned. Commercially, India imports about $400 billion US per year. The strategic import is $40 billion per year, and typically it is at the board level or system level or in terms of high value chips. The national needs which have been identified in the National Policy on Electronics in 2019 focuses on strategic needs in defense and aerospace, critical infrastructure, development of smart cities, e-commerce, banking, secure voting, solar power, power electronics, radio frequency, and optical communication. Semiconductor, we have the existing infrastructure, which is basically based upon one of the core sector is the semiconductor lab in Chandigarh, where we have development of VLSI devices and development of systems for telecommunication and space sectors. This Chandigarh laboratory has facilities for fabrication of microelectronic devices up to about 180 nanometers, and it has facilities to fabricate MEMS systems. India has a very fast-growing electronic system design manufacturing industry. Also, it has a strong design base with more than 120 units. We are in the process of setting up semiconductor foundry system, and there has been tremendous amount of thinking on such subject. The semiconductor laboratories, a unit owned by Indian Space Research Organization in Chandigarh, and Sitar, a unit of DRDO, each of which builds silicon chips for defense and space needs. The Indian Institute of Technology, Bombay, has a Center for Excellence in Nanoelectronics, which has a lab-like facility in collaboration with the Indian Institute of Science, Bangalore. The Indian Institute Center for Nanoscience and Engineering was established in 2010 to pursue interdisciplinary research on the nanoscale. We have a major center for supercomputing, which is called CDAC Pune. It has been entrusted with the mission of development of an indigenous design of a family of microprocessors, IPs, SOCs, and ecosystems supporting the product development to meet the India's requirement of strategic industrial and commercial sectors and supercomputers and the high-performance computing systems. So India's future, what we are looking at? We are looking at different kinds of devices. It's a batik of fabrication ecosystem in which the focus is on analog and the mixed signal, digital devices, memory, flash and DRAMs, then of course MEMS and silicon carbide based systems, photonics and gallium nitride based systems, different kinds of sensors, discrete devices. So the path is basically to incentivize the MNCs and national players and to create a manufacturing infrastructure and create a strong R&D and IP and engineering talent. The R&D center is the vehicle for strategy. That is our focus. Because when we compare, China has about 170 fabs. So I think it's time that we have certain at least 2 to 3 fabs as part of this boutique. So our semiconductor focus is based on research and development. For long-term self-reliance in the semiconductor, the government is considering setting up a dedicated research institute on the similar lines of IMEC, Belgium. This institute will be research-only institute with focus on semiconductor process, new materials, sensors, and new edge technologies. It will encompass National Institute of Semiconductor and Electronics Research, also institute with focus on applied and fundamental, and probably a budget provision of the order of $1 billion over a period of $1 million over a period of 5 years. The R&D fab should aim at incorporating all the processes involved akin to a fully functional manufacturing line, perhaps discounting only on the packaging part, which can be outsourced if needed. The R&D center will have a technology collaborator identified, and that is where I think TSMC and companies from Taiwan can play a major role so that the transition from one process to the other is seamless and in a holistic manner. The R&D activities required to be carried out in the fab will be identified as well as products that will be produced in the fab. The R&D fab will have limited production capacity, and it is important to run it as a revenue generating model to self-sustain. The fab would be managed and run by a professional management agency rather than purely the academic institutions. So in the light of all this, when we are planning to do this, there is a significant possibility of India-Taiwan partnership for driving this change. And this change can happen in 4 quadrants. Government to government, where we can implement a strategy and conditions for innovation, and also lead through the retooling of our programs. And we can bring in a marquee customer there. As far as the universities and colleges are concerned, I think there's a fairly good chance in this approach to develop curricula and skills for the innovation economy and connect learners to business and business to the research. That could be done through our cooperation. The private sector, that means industry to industry, should be actually made to make investments in R&D and ICT adoption. Need for patient capital and local on disruption technologies as like artificial intelligence and quantum computing and so on. And of course, there is a civil society where there will be a significant amount of benefit for both the countries. To conclude, I would say a semiconductor R&D center is needed for cost-shared translation of R&D to manufacturing, for commercial and strategic products, for consistent technology and product development, initiation and leadership. That is the focus of R&D fab. Since corporate research is expensive, we must work towards research co-sharing. Government shall provide consistent cost sharing vis-a-vis startups to support them. Programs and funds for disruptive technology and incubation will also be harnessed. So the way forward is that India must emerge as the next major semiconductor chip designer and manufacturer in the world, given its strategic importance for the nation. A risk-seeking mindset of entrepreneurs and venture capitalists has to be harnessed in this area. We have to create a homegrown, fabless semiconductor design ecosystem and harnessing local talent and helping nurture academic institutions as well as startups. Taiwan can act as a technology partner in setting up a mega fab and an R&D fab, research and development institutions, and supporting the Indian ecosystem to go from the numbers what I have mentioned to what we have projected. Long-term technology development relationship with Taiwan will catalyze the economic growth in both countries. So this platform, I personally believe, should certainly be the catalyst for bringing this cooperation to a level so that India's vision for improving its semiconductor ecosystem, going to the level of $410 billion of production in the country and having a high GDP can be achieved. And that will also promote the economy of Taiwan and economy of India. So I wish good deliberations, good discussions on this platform. And finally, if a roadmap can be worked out, some strategy can be worked out to bring this collaboration to the reality and fruition. Thank you very much for giving me this opportunity.